This week, we're learning how to analyze the phenomena of the emission of specific light waves or other electromagnetic waves from electrons in an atom as they go down from an excited state, from being energized, back to a ground state. When those electrons shed that energy that they got from being excited, the more energy they shed, the higher the frequency. And we covered this in our previous video. Do check that out if you are still not understanding of that quantum effect. So what happens though is that a lot of high school students are still a little shaky on how to actually do these types of calculations in their calculator and how to present them appropriately in scientific notation. So let's take a look at an example of this so we can see how we can best do light wavelength calculations and give the answer in the most readable, scientifically accurate way. So we see here that the speed of light is 3.00 times 10 to the 8th power. That meters, that is per second. That is 30 million meters per second. So in the old-fashioned way, we did base 10 notation like this. You would have your base here. That's the leading values. And then you would have our power 10 and then the exponent. So the more contemporary way and admittedly quicker way of writing is the 10 times 10 to this is replaced by an E, a capital E. Please don't ever use lowercase e. That is universally understood as Euler's number, totally different value altogether. So the way that most calculators that high school students in the United States represent this type of number is some variation on the Texas Instruments design, where your base value is typed in, and then you hit the second function button, which basically changes the use of each button to the little operator that is above the button. So on a lot of TI calculators, you have a comma button, but if you put that to the second function, you will see the EE, the double E. That is sort of Texas Instruments shorthand for this. I don't know why they do it like that, and they don't have just a single capital E, but it is what it is. So if you do it that way, then you should wind up, it will return this value. Now some calculators though just simply do you put in your base and then you hit the 10 to the X, and that punches in the time 10 to the, and then you put in the number and that fills in the X. So some calculators do it that way. Either is fine. They are the same thing. So let's say we now know how to do that. And we do this type of question where we have the question asking what would be the wavelength of a wave of a particular frequency. In this case, 7.53 times 10 to the 11th hertz. So this would be like 753 billion hertz. So taking the light wavelength relationship, which once again is speed of light equals wavelength times frequency, we manipulate this to speed of light divided by frequency will give us the wavelength. Now, the answer though could vary in your calculator depending on how it is set. You may get, I guess, what you would call just a regular number that is not in notation, that has a bunch of leading zeros like this. And that is an accurate answer. But it's also a tedious answer to write, and eventually we'll be wanting to where I want you to put all of your answers in these types of problems in notation, and definitely in college that's the way they want it. So a real quick little primer on scientific notation in this case, if you're not familiar with this, is that in scientific notation, what you're doing is you're changing the number so the leftmost non-zero digit is in front of the decimal. So we either have to move the decimal to the right or the left to get a base like this. So in this case, we had 0.000398. So if we move the decimal place 4 places, we get to the leftmost non-zero number, which is 3. So then the question is, well, what about all these trailing values? At what point do we round? So the best way to view this in this case is, if you'll notice, the values that went into this have 2 decimal places, 2 digits after the decimal, so we would round the answer the same way. We can just simply chop this off. Because the trailing number 4 is not 5, 8, 5, 6, 7, 8, 9, we won't round that 8 up to a 9, we just keep the 8 the same. So since both the values that went into it have a base of digit, decimal, 2 digits, we'll round this to the same thing. And then you will see that we basically got rid of all these leading zeros by indicating that we move the decimal 4 places to the right. If you have to move your answer 4 places to the right, your final exponent is a negative exponent. However, we could go back and take a look at the speed of light, which has a positive exponent. That is because the speed of light is 30 million meters per second. So in this case, if we're wanting to round down to a base of 3 digits and we want only 1 digit in front of the decimal, we move the decimal place 8 spaces to the left. So that explains why we have a positive exponent. We move the decimal place to the left. So a movement of the decimal place to the left will always give us a positive base 10 exponent, and then a movement of the decimal place from a normal number to a notation to the right will give us a negative one. And hopefully this is key to the idea is that this exponent, when we're dealing with base 10 values, is basically counting how many placeholders we have. That's really all it represents, because I could take this number and undo it and turn it back into a normal number this way. The scientific notation is nothing more than mathematical shorthand to chop down big, long numbers that tend to have lots of trailing zeros or bunches of leading zeros, so you're not filling up a bunch of unnecessary zeros. So this is how base 10 exponential notation is written. I'll probably have a separate video devoted to just more practice just on this idea. And this is actually a really important idea, because if we're able to get to acid-base chemistry, that base 10 exponential values are the way that we measure the acidity of a particular solution. Base 10 scientific notation is found everywhere in math and science. So this is definitely a skill you want to be getting into as soon as possible.